Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of the International Fuel Gas Code, Chapter 4. My name is Thomas, and in this presentation we are going to look at sections 407 to 410. Plenty of great stuff to cover in here. Let's get started. Let's get right into this. 407 is about piping support. It's not a long section, but here I've included a big chunky paragraph coming out of 407.2. I'm going to read this. I want you to pay close attention to the repetition of a word. See if you can find out which word it is. Piping shall be supported with metal pipe hooks, metal pipe straps, metal bands, metal brackets, metal hangers, or building structural components suitable for the size of piping of adequate strength and quality, and located in intervals so as to prevent or damp out excess vibration. Did you notice the repetition of a word in the beginning of this paragraph?
Support gas pipe for metal! Support gas pipe for metal! Support gas pipe for metal! Support gas pipe for metal!
Gas piping is to be supported with metal supports. Now, plumbers, we use plastic supports for plastic pipe, drains, and water lines. We use plastic plumber's tape. We use plastic J-hooks, tube talons, and other supportive materials. But when it's time to install gas piping, we need to install metal. There are plenty of options for metal supports. You can use metal plumber's tape. You can use metal pipe straps, two-hole straps. Metal unistrut and metal unistrut clamps are also an option, as we see in this support that is on an exterior roof location. Clevis hangers and many other types of supports. Just make sure they're metal.
Support gas pipe for metal! Support gas pipe for metal!
Look at 408 with me. This is about drips and sloped piping. This is also where we learn about sediment traps. Some gases have more potential for condensation than others. Dry gas is what's typically provided at natural gas systems. But again, some other types of systems may actually condense within the piping. If that's the case, we have to provide slope to the pipe and what are called drips or drip legs. Now, people use these terms interchangeably, a drip leg and a sediment trap or dirt leg. May I point out, according to section 408, that they are slightly different, and different in the ways that they would be installed. A drip is going to be installed in a pipe so that any fluids that may condense or collect from the gas would be dripped down into that leg. You can see here there's a length of pipe, a T, and a small leg with a cap. When these are installed, according to 408.1, the pipe is required to be sloped, but the slope can be very minimal. You know, over in drainage, we're talking 1/4 inch per foot. Now we're talking 1/4 inch per 15 feet. That's barely any slope at all, but enough that whatever would collect is going to drop into the drip leg. 408.2 states that anywhere in the pipe system where condensate could collect, we need a drip. And there's another important place that we would need that, and that's right after the meter, so that none of that could ever collect and clog up the meter. So one just past the meter and then wherever necessary throughout the system. The location of these drips should be somewhere that has ready access. That way, these drips could be cleaned out if necessary. Now let's get to what we're more commonly involved with, and that is the sediment trap. The sediment trap has a slightly different purpose. It is used on dry gas systems, and its purpose is to collect any sediment or dust that would come pushing through with the gas and could possibly cause damage or problems with the appliance. So let's look at a number of the requirements specific to the sediment trap or dirt leg. It should be downstream of the appliance shutoff. Every appliance should have a separate shutoff valve, and it should come after the valve, not before. It should be as close to the appliance as possible. The sediment trap is crafted by installing a T with a cap and a nipple. The leg can be any length. Can be any length of pipe. 4 inches is probably a good rough standard for that. A close nipple is probably not enough. A 6 is fine. A 12 is probably too much. Now the leg has to come from the bottommost opening of the T. It is not to be installed as we saw with the drip leg. It could be in a horizontal position. This specifically needs to be in a vertical so that as that gas is coming in, the sediment will go down and not be pushed straight across through into the gas valve. Here's a diagram for the correct orientation of a sediment trap. We see at the top a shutoff valve that is specific to that appliance. Coming down, we have the T with a nipple and a cap. The sediment trap is the cap and nipple down below. Between that and the appliance, there is a union or a way to connect and disconnect. That can also be a flex connector, but in this illustration, we're dealing with rigid metallic pipe.
Sediment trap gonna collect the dirt. Keep the appliance so it doesn't get hurt. Oh, yes! You know you wanna sediment trap.
408.4 also lists out some places where the sediment trap is not required. Here they are. Illuminating appliances, that would be appliances used for light. Ranges, or a gas range that you would cook on in the kitchen. Clothes dryers. Decorative vented appliances such as fireplaces, vented fireplaces, or outdoor grills. Now, is it a good idea to install a sediment trap at these locations? Actually, yes. It's always good to have a sediment trap. The logic behind these exceptions is that all of these are manually operated, not automatically operated like a water heater or a furnace, and therefore if there was a problem with them, you would see that and you would know to get that fixed. Still, dust will do damage, so put in a sediment trap if you can.
Oh, yes! You know you wanna sediment trap.
Let's go on to section 409, which is about shutoff valves. 409.1 gives us the general that a valve must be approved and comply with the standards, as with any materials that we find in code. 409.2 talks about the meter valve and how the meter has to be equipped with a valve on the supply side of the meter. This makes perfect sense, right? If there's a problem with any of that, the regulator, the meter, or anything downstream, we want to be able to shut it off at the source. So as soon as it comes up, we want it on that supply side. 409.3 gives us specifics about shutoff valves for multiple house line systems. Let's say here that we have a building with 3 different units. There's a regulator, the meter, and then the gas line goes into the building and branches to the different tenants. Each of those should have a separate shutoff or the ability to control the gas to that unit without interrupting the flow of gas to the other units. This makes perfect sense because we want control in individual spaces. 409.4 gives us the requirement for valves by the MP regulator. That's going to be a moderated pressure regulator. In this case, the valve has to be immediately ahead of the regulator. We want to be able to control that and have that control close by. 409.5 talks about the appliance shutoffs themselves. This section states that the shutoff valve should be located in the same room as the appliance and within 6 feet of the appliance. It shall also be accessible. We need to be able to get to those valves. 409.5.1 is where it specifically states that the valve must be located in the same room. Take a close look at this picture. Do you see anything wrong with it? Think back to the beginning of our presentation on supports.
support gas pipes better!
I can see it. It's a plastic plumber's tape that's not going to be approved as a support for this metal pipe. One other suggestion. I have been taught since my early apprentice days that it's best not to have a valve facing down with the handle. Sometimes sediment or other junk will collect in the handle stem, and that can over time make it leak or hard to open and close. So the orientation of this is not ideal. 409.5.2 gives us a little more direction on vented decorative appliances and room heaters. It says that the valve is permitted to be in a remote area. That means we might have that valve located somewhere other than right there at the appliance, but it does have to have ready access. I should be able to walk right up to it and turn it off. Now, if it's not right there at the appliance, it's going to be important that it's permanently identified. That way I could walk up to it and see exactly what its purpose is. If I turn off this valve, it's going to shut off that appliance. It also states that the valve shall not serve any other appliance. Maybe there's a branch with more than one appliance in that area of the house. Well, we still need an individual valve for each appliance. Finally, the piping from the valve must be within 6 feet and must meet the code standards. Now, what if we're running flexible tubing and using a manifold system? The code does not leave us without some flexibility. Sorry, I had to throw that pun in there. Check this out. From the manifold, if I do a manifold and I'm sending gas lines out to appliances from there, that's all right, but there is a limit of 50 feet from the manifold to the appliance. And then we can have all those valves right there at the manifold together. Now, once again, these valves are not going to be located immediately by the appliance. So we'll need to know which one is which. And that's why they have to be permanently identified. Once again, within 50 feet, readily accessible, permanently identified, and the pipe within 6 feet of the appliance must also meet the code, whatever we're using to connect at the other end. 409.6 talks about shutoff valves for laboratories. If there are valves at the individual workstations, there still should be another valve that will shut off all of those valves. They're calling it a single dedicated shutoff valve to control them all.
One valve to rule them all.
409.7 shutoff valves in tubing systems. Let's go back to the scenario where we're using CSST. We're flexing that pipe all over the place. What you don't want is for that tubing to come out to the location of the appliance and be able to move and flex and be pushed all around. This section states that the valve should be rigidly and securely supported independent of the tubing. We see that in this illustration. The valve is connected to a plate. That plate can be secured to flooring or to a wall, to a stud. But that way it has a rigid connection. Now, why do we need that? As we're turning that valve on and off, what we don't want to do is create torque or turn or tension against the tubing, or it could possibly wear out and leak. So this rigid connection at the point of the valve makes sure that as we're turning it on and off, it's not going to damage the tubing. 410 gives us information about flow controls. Many gas systems have a higher pressure at the source than what we need at the appliance. So we have to bring that pressure down. Appliance pressure is actually really low. Typical gas pressure at an appliance is 0.3 inch water column. We're talking 4 ounces is another way that's referred to, and it's very low pressure. Whereas at the street, it may be much higher than that. When it comes into the building, there's a regulator. The regulator is usually before the meter. And then coming into the building, we have a pressure. Now, there are options for that meter and the pressure valve at the meter. You could set it right to that 0.3 inch water column. Or if you need more gas supply, you have more appliances or higher values or small pipe sizes, you can bump that pressure up to 2 psi. That's delivering a lot more than is needed. And at the appliance, you would add another regulator to bring that pressure down to where it should be. Remember what we learned from gas pipe sizing, that the pressure will directly affect the size of the pipe, and the size of the pipe will directly affect the cost of the system. So if we go higher pressure, we can do smaller pipe, save money on the pipe, add some regulators. That is one common strategy when it comes to gas piping systems, and that is why we have to know about flow controls. Now, whenever there are flow controls, code requires that access is provided. 410.2 talks about MP regulators and gives a series of very specific requirements for when these are installed. These requirements are numbered and listed in this section, and here they are. 1, they have to be approved devices for regulating pressure. 2, they have to maintain reduced outlet pressure. That means as they're bringing that gas pressure down, they keep a steady flow at the lower pressure. 3, the capacity of the regulator is to be determined by the manufacturer. They will set that pressure and we simply install. 4, access is required. We have to be able to get to these for service. 5, it requires T-fittings before and after the regulator. 6, the downstream T past the regulator must be 10 pipe diameters downstream from the regulator. This is for testing purposes. To get an accurate test, if we need to know whether this regulator is doing its job, it needs a little bit of space away from the regulator so that pipe fittings or other things are not interfering with the reading of the pressure as that gas flows through. Number 7 says that a rigid union must be installed within 1 foot of either side of the regulator. This way, if we need to replace the regulator, we can undo that union, remove it, and reinstall a new one. Here's an illustration of the required setup for a gas regulator. Pay close attention, this is exactly what we just saw on the list. From the left, there's a shutoff valve. Then there's a T, this is a testing port. We have the regulator after the T, and 10 pipe diameters downstream, we have another T for the purpose of testing. Finally, within 1 foot of the regulator, we need to have a union. Now, that union could be on the other side, it could be closer to the regulator, it could be anywhere within a foot, but it needs to be there. 410.3 gives information about the venting of the regulators. Some regulators are designed to be installed indoors without a vent. On the other hand, some require a vent to exhaust out that little bit of gas that is emitted as they are regulating the pressure down. In that case, a regulator that is installed indoors would have to have a vent pipe that runs to the outdoors. That pipe would need to have an insect screen or some way to prevent insects from getting into it, and that vent pipe is not allowed to be any smaller than the connection that it has to that regulator. 410.4 talks about excess flow valves. Here's an example of one of those, the Watts Dormont Smart Series. What this valve does is it closes the supply if the pressure increases to a level higher than should be put into the appliance. These valves are fairly simple in function, but they do a good job of closing off that supply line if the pressure is too much for the appliance. Now here's another side note on these. Some appliances, like the Navy and tankless water heaters, they have the ability to actually pull in gas faster than it's flowing. In this situation, one of these excess flow valves would be problematic for that Navian, and it warns against using those. Because as that water heater is drawing and then needs more gas and starts pulling it, it's going to close off that excess flow valve. So there are some situations where they are not to our advantage, but those appliances are going to spell that out in their installation manual. Finally, we have 410.5, which is about flashback arrestor check valves. These are a little more rare case, but when there is a fuel gas that is used with oxygen, and you have two coming together at a valve with different pressures, these valves prevent the flow of one gas into the other, and these serve as a backflow check valve for either line. That way we don't get gas mixing where it shouldn't.
Support gas pipe for metal! Support gas pipe for metal! Support gas pipe for metal! Support gas pipe for metal!
All right, that does it for sections 407 to 410. In these sections, there are several things that I imagine you deal with all the time as you're installing gas pipe. And pay close attention to the piping orientation when you're installing sediment traps, keep it vertical, and regulators. Make sure you have the correct series of T's, union, and the regulator so that it is installed correctly. Join me in the next presentation and we will finish off Chapter 4 from the International Fuel Gas Code. I'll see you then.